Hello everyone. Uh, in last video, we done dispersed phase and dispersion medium meaning, and next we will start the classification of colloids. The first classification is based on physical state of dispersed medium and dispersed phase and dispersion medium. So there are total 8 types of colloidal systems on basis of physical dispersed phase and dispersion medium. The first is solid in solid. So all colored gemstones are the examples, and this is known as solid soot. Then next is soot, which is solid in liquid like paints. Next is aerosol. So aerosols are of 2 types. The first aerosol is solid in gas. Uh, the colloids in which the medium is gas are known as aerosols, are always known as aerosols. So this name is based on the dispersion medium state, right? So aerosol because medium is gas. Solid in gas is smoke, like carbon in air, dust, dust particles in air, suspended in air. Then gel, liquid in solid, cheese, jellies are the examples. Emulsion, liquid in liquid. Emulsions are the colloids in which liquid is dispersed into a liquid. Milk is an example. Hair creams. The next aerosol is liquid in gas. Mist, fog clouds are the examples. So water droplets, tiny water droplets floating in the air is example of liquid in gas type of colloids. So here all these particles, the dispersed phase particles are of size in between 1 nanometer to 1000, right? So next is solid salts. So gas is solid, foam, foam rubber, device stones. Are those which have holes on them, right? And foam rubber is normal your cushions, uh, uh, like or the any type of cushions, any type of foams we use in our homes on beds or on sofas, on chairs. So all this comes under this category. Foam. Next is foam, gas and liquid. Whipped cream. The cream on the cake, it's made from the normal cream. And it contains, it is fluffy due to the presence of air, more air in it. And liquid is there, and air is inside the liquid. Now, the important part is how the question will be asked from this part. Uh, Generally, they put uh, questions like this: what are emulsions? Give 2 examples, right? So the emulsions are the colloidal solution in which both dispersed phase and dispersion medium are equal. So what are aerosols? Aerosols are the colloidal systems in which dispersion medium is gas and dispersed phase may be solid or liquid. You can give examples for the both, right? So this is the classification of colloidal solutions on basis of physical state of dispersion medium and dispersed phase particles, right? The next classification is based on the type of interactions in between them. So we have 2 types of colloids on basis of interactions forces in between the dispersion medium and dispersed phase particle. First is lyophobic and the other one is lyophilic. So lyo means liquid, phobic means hating. So lyo is liquid and philic means loving. So lyophobic are liquid hating. Particles, dispersed phase particles, do not have affinity for the medium in which they are suspended. So these are not stable. So they need stabilizing agent for their preservation or preparation. They are irreversible. Irreversible means once they coagulated, uh, it means once they disturb, they cannot be retrieved. They cannot be uh, uh, again in the colloidal form. Once they have been coagulated, they cannot be changed back to the original form of colloidal system. Lyophobic colloids generally disturb uh, even with a small quantity of electrolytes, right? So lyophilic, on the other hand, are liquid loving. Particles have affinity for the dispersion. They are quite stable. So they do not need any stabilizing agent in them. And they are reversible. So it means अगर हमने इसमें से dispersing medium निकाल भी लिया है, तो if we add again, so they will form again. So starch so time, right? Next classification is based on the types of particles, dispersed phase particles, types. Which type of particles are there? So the first category is multi-molecular fluids. So in case of multi-molecular fluids, the dispersed phase particles individually are of less than 1 nanometer size, but they exist in forms of aggregates, and those aggregates are in region of 1 nanometer to 1000 nanometer, that is in vital range. So due to the aggregates, they become the colloids. Otherwise, the individual particles are less than the 1 nanometer. Sulfur sol, gold sol are the examples. Sulfur sol consists thousands of S8 molecules together to form colloidal range particles. So they are multi means many particles joined together. Right? So next type is macromolecular colloids. Now macromolecular colloids, those having high molar mass are known as macromolecules. So when these macromolecules dissolved in some suitable solvents, so they form solution. And these macromolecules, because in range of colloidal particles, so these solutions are colloidal solutions, and the solvent becomes dispersion medium. So naturally occurring macromolecules, starch, gum, cellulose, protein. So if we will make a solution of starch by dissolving, by making the paste of starch first, and then we will dissolve the starch in hot water. We'll get a solution in which the starch is a macromolecule, and it gives the particle size, dispersed phase particle size, colloidal range. So this type of colloids become macromolecular colloids. So only single particle is in range of colloidal particles. And the third one are the associated colloids. So associated colloids are also made by the aggregates, but in case of associated, how they differ from multimolecular. In case of multimoleculars are always have always particles in aggregates in form of aggregates, but in case of associated colloids, these substances behave normally at low concentration. So they behave as normal electrolyte, right? Normal true solution characteristic. But at a certain concentration and at a certain temperature, they form aggregates. Two conditions are there, temperature and certain concentration. Only they can form aggregates. And these aggregates, in case of associated colloids, are known as micelles. And the micelles can be formed only above a particular temperature for a substance, that is known as temperature. and above the certain concentration, which is known as critical micelle concentration. So these are the normal substances, normal electrolytes at low concentration. So at the higher concentration, they show the properties of colloids due to the formation of aggregates in them. So the aggregated particles are known as micelles in them, and micelles can be formed only above a particular temperature, which is known as Kraft temperature, and above a certain concentration, which is known as critical micelle concentration. Right. So soap solutions, detergent solutions are the examples. Now, mechanism how this micelle is formed. Now, the soap solution has the soap solution has particles in which two parts are there in soap molecule. Soap contain a long tail which is hydrocarbon and is water hating and is non-polar, right? And the other part is polar and is known as head and is hydrophilic. So there are two main parts in a soap molecule. So soaps are the higher fatty acids of sodium or potassium. Like here is an example by me is sodium stearate, which contains 17 carbon atom chain. This is the structure. So 17 carbon atom chain, and at the end of the chain, the carboxyl group is attached with negative charge. So it is a salt, sodium is there. So when we put it into water, it gives two ions, RCO negative and Na positive. So the R, the chain is nonpolar, long hydrocarbon chain and is known as pair. And the COO part is polar and hydrophilic water. So now if we add this into the water, so what will happen? The water-loving part, is at the surface of the water, and the water-hating part keeps itself out from the water. But at critical micelle concentration, the concentration of these two particles is enough to make micelle. Then they arrange themselves in this manner. So all the water-loving, so they repel the water from this part, and the water-loving part arranged outside, and inside the water-hating part, that is tails of all the molecules joined together in this manner in the center, and at the surface water-loving part. So they form ionic micelles, and to form the micelle, at least minimum 100 molecules should be joined together by pointing hydrocarbon chains towards the center of the sphere and heads outside on the surface of the spherical shape. Right? Now, cleansing action of soap, or soap cleans the stains or the dirt on the surface of the floor. So this is an example. This is grease stain on the floor. So when we apply soap on a wet floor, what will happen? The water-loving part outside keeps itself outside, and the water-hating part, like dissolve like, as this is non-polar, grease is non-polar, stain is non-polar, dirt is non-polar. So the non-polar part embedded into the grease. So when we apply force on the floor, the soap molecules get disturbed from there. They take the dirt along with the uh, hydrocarbon part of the soap, hydrophobic part of the soap, and they take it into the they take it into the water and form micelle, and this is the dirt inside, and keep the dirt inside. So this is how they remove the dirt or grease, whatever. So this is how the soap removes the stain or the grease of the surface of a cloth. Because it has two parts, water loving and water hating. So the generally dirt, grease, oil stains are non-polar. So the non-polar part of the soap gets embedded into the non-polar substance, that is dirt or grease. And when we pour water over the cloth, so the soap molecules flow with the water and they take the dirt along with them. Why they take the dirt along with them? Because what hydrophobic part is already embedded into it. When we uh, brush the cloth, so the dirt disturbed, and those hydrophobic part capture the dirt along with them and forms micelle like this, the water, and keep the dirt away from the cloth. Now, next is methods of preparation of chlorides. There are many methods, but only three are given in our NCRT. So and you will be asked questions from those only. Right. The first method is chemical method. So there are few more reactions are there, like the double decomposition, reduction, oxidation, three, four methods are there under the chemical method. So this chemical method includes a normal reaction in which molecules are formed and those molecules aggregate to form the salts. Right? Simple. So here is the first method: reduction of gold to gold compound. AuCl3 plus stannous chloride gives gold salt. Like here is H2S plus Br2 gives sulfur salt. Hydrolysis of ferric chloride also gives colloidal salt of uh, ferric hydroxide. Right. Next method is electrical disintegration or Bridges arc method. So what we'll do in this method, the dispersed phase particles, the substance of which we require the dispersed phase particle, we made electrodes of that substance and put it into the dispersion medium and apply a high voltage current. On the application of high voltage, so this electrodes melts and the dispersion medium is kept inside the ice. So uh, it has very low temperature. As the droplets out from this electrode, so they freeze in the range of colloidal particles. So electric arc is struck between the electrodes of the metal. So here is an electric arc which is struck into the metal electrodes inside a dispersion medium. So intense heat is produced, which vaporizes the metal of electrode and condenses to form the particles of colloidal. Right? And the last method is baptization. So baptization is a process of conversion of precipitates to colloidal particles. Precipitates are larger particles, and baptization is a process. Baptization is a process, and this process is done in many ways. And the one of the common method is by the baptization, the method where we add small amount of electrolyte into the freshly prepared precipitates, and those precipitates get converted into the colloidal particles. Now, how this works will come later uh, in, later in the syllabus. But the electrolyte added, the main principle is the electrolyte we add into the freshly prepared precipitates will create a charge, common charge on the particles of dispersed phase, and that common part, the charge keeps them away because like charges repel each other. So that charge keeps them away from each other. So this is how the colloidal particles form. from an aggregate, from a precipitate, right? So there are some examples we'll discuss later for this, how it is prepared, right? So this is all for classification of fluids and methods of preparation of colloidal solutions, right?